for DSCI 560 Lab 3. Our project is a stock price manager. In this part, I'll introduce how we collect the data using the Yahoo Finance API and store it in the database. So as we can see in this data collection.py file, we have several functions. The data retrieval function retrieves the data from the Yahoo Finance, and there is a database connection function which connects to the current database, and also a table creation function which creates a database, a table, and store the data that we retrieved into the table. So if we run the script in the command line with a few arguments, including the name of a portfolio and a start date and an end date, then the users can store exactly the data that they want in the database. Once the command is run, then the data is automatically retrieved and stored. Now let's take a look at how the data appears in the database. So as we can see, there is a database called stock, and under this stock database there's a table called prices. If we have a look at the prices table, then there are several columns: the ticker, the date, close price, high price, low price, open price, and the volume. And the primary key is the combination of the ticker and date. So that's how the data collection works. And next, my teammate will introduce how the data can be used and operated by users.
Hi, this is a video demonstrating Lab 3 assignment for DSCI 560. So in our case, let me just show the files that are in our repo. So I'm currently in the virtual environment, and to run our stock portfolio script, we just run it with Python. And then the way we implemented it is as a command line interface. So it basically prompts the user for a menu of options that they can select from. In our case, we made it 6 options. Well, 5 really. The 6th one is just to exit the program. But so we can create a portfolio, add a stock, remove a stock, list portfolios, or fetch prices for a specific portfolio. So I'll just quickly run through an example. So if I create a portfolio, I'll just give the name. I can add the stocks that I want to, initially add to my portfolio. So in this case, I'll add Google and Apple. I get some feedback that it was added. If I now list the portfolios, these are some previous ones, but this is the one that I just created. And then I could remove a stock, for example. So if I call out that specific portfolio, let's see, I'll remove Apple from it. So if we check the portfolios again, you can see that Apple was removed, and I could re-add it. Just double check, and you see it was added again. And finally, we can fetch the prices for a specific portfolio. So let's look at this one. So it has the option, or we give the option to specify a start date and end date if you want. Those are optional though. And then you can also specify a period that you want to be looking at. So let's say I only want to look at the past month, and then I want to look at intervals of 1 day. And then that gives me the daily intervals for the past month for both Apple and Google, since those are the stocks that I have in my portfolio. And then I can exit the program. In terms of our code, all of our code is in the stock portfolio file. In terms of the data that we're loading and reading from, we created 3 tables in our MySQL database. The portfolios table, it just stores the portfolio level data. And then we have portfolio stocks table, which stores which stocks are associated with which portfolios. And then we have a prices table that basically stores all the stock prices that have been fetched. And this isn't associated with specific portfolios because these are just related to the stock itself and not to a specific portfolio. So it's sort of like a caching table. Like when a user fetches, let's say, the daily intervals for the past month for like Apple and Google, we'll store that data there. And then if they refetch that same query but in the future and we don't have like the latest daily information, for example, we'll go through the Yahoo API, get the latest data that we're missing from this table, and basically update this table accordingly. And then if they want some historic data that we already have in the prices table, then we'll just pull it directly from the prices table. And then we have basically the functionalities here for each menu option that you saw. So in our main method, which is this one, essentially, we have some logic for accounting for each menu option. Thank you for watching.
Hello, I'm going to introduce the data pre-processing part of our team before the stock price prediction. We first connect to the MySQL database. Then we get all of the table name of the database, and we can see that there's only one table name prices in our database. So we load the SQL table name prices into the pandas data frame, which is the tables that we are going to pre-processing in our project. Then we print out the first 5 rows of the table, and we can see that it has the features, the tick, which is the stock name and its date, close price, highest price, lowest price, opening price, and the volumes. Then we check the dimension of the table, which is 750 rows and 7 columns. Now we are going to deal with the missing value in the table, so we check the number of missing values in the table, but we can see that there's no missing value in each of the columns of the table, so we do not need to deal with the missing value for this stock price table. Now we convert the date column, which is the timestamp column, to the datetime type using the pandas to datetime function. Now we are going to define some matrix that will be helpful for the later stock prediction. And for each of the matrix, we are going to create a feature in our table to store the values that we are calculated and compute here. The first matrix that we are going to define is the daily return. It measures the percentage change from the previous day's close price. We also define the log version of it, which will be more stable for the modeling. We then define the daily range matrix. It measures the daily volatilities. We also define another 2 volatility matrices. It measures the fluctuation, which is also the risk in a 5-day period and a 20-day period. We then define the moving average matrix. It smooths the price trend in a 5-day period and a 20-day period, which is helpful to see the underlying trend in a period by filtering out the day-to-day noise. We also define the volume change matrix. It measures the percentage change in a volume of the stock. We also define the moving average of the volume change in a 5-day period. The final matrix that we define is the open-close gap. It measures the overnight price jump of the stock. After defining all of the matrices, we print out the first 5 rows of the matrix of the table, and we can see that now we have 17 columns instead of 7 columns by adding all of these matrix into our table. That's all of our data pre-processing part. Thank you for listening.